Mr. Samuels here with a continuation of our discussion of atomic theory. Last time we learned that atoms are made of protons, neutrons, and electrons, and today we need to ask the question, what makes each element different? Turns out it's the number of protons in the nucleus. This number is given a special name. It's called the atomic number. You can find it on the periodic table. So this means that, for example, lithium has 3 protons, every lithium atom. It's also important to note that for neutral atoms, the number of electrons is equal to the number of protons, so the positive and negative charges balance out. So what's up with this other number on the periodic table? That's called the average atomic mass. Now, if you remember, protons and neutrons are the parts of the atom with significant mass. So if you add those up, you should get the atomic mass. Now, wait a minute, isn't this a little weird that we have a decimal? You can't have 0.941 protons or neutrons, so why is that number have a decimal at all? Well, it turns out it's an average of all these different things called isotopes. Oh, and by the way, the units are AMU, atomic mass units. So isotopes are atoms of the same element with a different number of neutrons. Remember, they have to have the same number of protons to be the same element, but some are just heavier or lighter than others. Each one has a name, like carbon-13, and a nuclear symbol that includes the atomic number on bottom and the mass number on top. The mass number is just when you add up the protons and neutrons. So if we look at carbon-13, you see 6 protons, 7 neutrons, add them up, and you get 13. So this carbon atom acts the same as a carbon-12 isotope. It's just a little heavier. And we'll learn about why that's important later. Last thing you need to put in your notes is that if you are given the name or the nuclear symbol, you can find the number of neutrons by subtracting mass number minus atomic number. Remember, we saw the mass number was 13. If we subtract out the protons, it should give us the neutrons, and as you can see, 13 minus 6 is 7. A carbon-14 isotope would have 8 neutrons. Thanks for watching. Go ahead and try the rest of the practice problems on your own, and we'll see you next time.